Hello everyone! You guessed it, Mr. Fitry here again. Big surprise. Hey, today we are going to finish up our third unit here by looking at the theory of plate tectonics. So we're going to build on Alfred Wegener's hypothesis of Pangea and moving continents and how convection currents in the mantle cause seafloor spreading, mid-ocean ridges, and deep ocean trenches. All right. Tentatively, the goal is that we will have a test after this. All right. I do hope we can have a short review though first. Again, we're going to take this day by day depending on the situation with COVID. So everyone, our objective here for today is what is the theory of plate tectonics? Now, we see this picture here, and it basically outlines all the plates or the pieces of Earth's crust. We see that most of our continents sit on individual plates, like the Eurasian plate that has Asia and Europe, North America, South America, Africa, Australia, Antarctica. But we've also got some smaller plates, like the Arabian plate, right, where the Middle East sits, the Indian plate, where India is, the Philippine plate, you guessed it, where the Philippines are. And then you've got some smaller ones, like the Caribbean, Cocos plate, Nazca plate, and the Juan de Fuca plate. All right? So these are going to play a role in how the Earth is shaped. Vocabulary for today. We looked at some of these before. Some are new. First, diverge, separate, or go in different directions. Converge, meet at a point. Transform, make a thorough or dramatic change. And fault, a break in the Earth's crust where rocks slide past each other. So the areas that separate the pieces of the crust will be where faults are. So, our plates, like I was saying earlier, these are pieces of Earth's crust. Remember, Earth's crust is the outer part of the Earth. And these pieces are separated by cracks. Now, these plates are in slow, constant motion. This motion is driven by the convection currents in the mantle, and this movement is called plate tectonics. Now, if we look at this picture here, we see that the plates are moving in different ways. Some plates are moving towards each other or together. Some are moving apart. And some are just moving past each other. So let's look at those individual differences. So first, though, we have to understand that the convection currents in the mantle are strong enough to move the plates. We're talking about some of the strongest forces in nature. The convection currents in the mantle are strong enough to move land the size of continents. But they're not moving very fast. Most plates move between 1 to 12 centimeters per year. So, with this, you can guess that it takes hundreds of millions of years for the plates to get where they are today. However, as plates move, they change Earth's surface. They produce earthquakes, volcanoes, mountain ranges, and deep ocean trenches. So, over the next few classes and units, we're going to see how these effects create each of these natural phenomenon. So, where these plates meet, where these cracks in the crust are boundaries, which we call faults. So, we have three different types of boundaries, and then we'll see later on the three different types of faults. But first of all, we have divergent boundaries. These are where plates move apart or diverge. We have convergent boundaries, where plates come together or converge. And then we have transform boundaries, where plates move past each other in opposite directions. And you see each in the picture below. Okay? Divergent, moving apart; convergent, coming together; transform, moving past each other. Let's hone in on divergent boundaries. Divergent boundaries are where plates move apart or diverge, as we've mentioned. Now, these usually occur underwater at mid-ocean ridges. What we talked about last class, where the convection currents in the mantle are moving the ocean floor apart, allowing hot, molten material, magma, to rise up, cool down, form rock, and continually create new pieces of the ocean floor. However, there are some that occur above water. We call these rift valleys. The prime example is the East African Rift Valley, which you see in the picture there. You actually see the crack where the plates are being pulled apart. Now, what's critical to know is that at divergent boundaries, rock is created. Okay? Because as the plates move apart, it allows that hot material from within the earth to rise up, cool down, solidify, and form new rock. This is a lot of information, but we'll break it down. Okay, so with convergent boundaries, these are plates that come together or converge. Now, we have to understand that plates can act differently when they converge. And much of this is determined by the density of the plate. Generally speaking, the denser plate sinks or goes under the less dense plate. So, oceanic crust is more dense than continental crust. So as you can imagine, the oceanic crust is going under the continental crust. It's sinking below it, which is why we don't have, the ocean floor creeping up the side of continents. Next, this is because oceanic crust will subduct under the continental crust, which is less dense. And when this happens, while pushing the continental plate up, this interaction forms mountains and volcanoes. An example is the Andes in South America, where the Pacific plate is subducting or going under the continental plate, and you have these massive mountain chains that form the Andes, which include many volcanoes as well. When two oceanic plates collide, this is unique because of the water around it. It creates this cooling effect on the plates. And because of this, the plates melt more easily, and this allows magma to rise, forming volcanoes. When two continental plates collide, the density is almost equal, so it causes the plates to push each other up, forming mountain ranges, which is exactly how the Himalayas formed. You had the Eurasian plate and the Indian plate, both continental plates, equal density, hitting each other and pushing each other up. Again, critical piece here is that at convergent boundaries, rock is destroyed. Why is it destroyed? Because for the most part, one plate will subduct or go under the other plate. It will be destroyed. So here we've got our visualizations. The top one, we've got the oceanic crust colliding with the continental crust. Now the oceanic crust is going to go under the continental crust, and at the same time push up those mountains and potentially form volcanoes. The second picture in the middle, we've got two oceanic pieces of crust colliding. As they do, the cooling effect of the water allows for that hot, molten magma to melt the crust, push upwards, and form volcanoes. Finally, when two continental crusts, or two continental pieces of crust, I should say, collide, because they're about equal density, they're going to push each other up, forming a mountain range. Remember, at these convergent boundaries, rock is destroyed. It's destroyed as the pieces of the crust subduct back into the mantle to be melted and reused. Interestingly, I do want to point out this. Of course, with our convergent boundaries, you have the Himalayan mountains and Mount Everest, two continental plates colliding, forming the tallest mountains in the world. However, if you look at this map of Central America, Central America was formed when the Caribbean plate and a smaller plate collided. Two oceanic plates collided. And over millions of years, they formed volcanoes and formed this stretch of land, which is now Central America. But because it is two oceanic plates colliding, there are numerous volcanoes that have formed in Central America. if you see all those little yellow triangles, they're all volcanoes that are active or potentially active. Okay, you see a picture at the bottom there of Lake Atitlan in Guatemala, where you see a massive lake surrounded by active volcanoes. Finally, our transform boundaries. Transform boundaries are where plates move past each other in opposite directions. Now, because the sides of the plates are jagged and rocky, they can often stick together or lock in place. When these plates unlock, when they move, they cause earthquakes. At these boundaries, crust is neither created or destroyed. It just moves. Probably the most famous transform boundary is the San Andreas Fault in California, in America. Two plates are moving past each other in opposite directions, causing, first of all, a massive crack or break in the earth, but also causing many earthquakes per year. Some very strong, some barely noticeable. So, what is the theory of plate tectonics? Well, again, we've got these plates that make up the crust, pieces of the crust of the earth, and they are in constant motion. That motion is driven by the convection currents in the mantle. Some plates converge, come together, some diverge or move apart, and some move past each other. Each have different effects on the land where they meet. So, please make sure you review this unit and the other units we've covered so far. The plan is that we will have a test on these 3 units to see how we're doing. All right. Again, I plan to have a review and then the test. We'll just have to see how it goes depending on COVID. Great. Thanks so much. Have a good day.